In today's lesson, we're going to talk about density and intensive properties and extensive properties. So the physical properties of a substance are the characteristics of a substance that can be used to describe it. There's two types of physical properties, extensive and intensive, where extensive are directly related to the size and amount of that sample or that chemical, and intensive properties are not related to size and amount. So looking more at extensive properties, three examples that are the primary ones are mass, volume, and length. Mass is related to the amount of the matter in a substance. Think of grams and kilograms as units. Volume is the amount of space of a sample occupies. We usually measure volume with a graduated cylinder in the lab. On the right, there's a picture of the graduated cylinder. And length, we usually measure with a ruler. And you might see units like meters or centimeters. Width and height are also lengths. States of matter are solids, liquids, and gas, and temperatures such as boiling point and the melting point of a substance. Density is another important physical property of matter. Density is a comparison of how much matter there is in a certain amount of space. And density tells us a relationship between mass and volume. Now, density is an intensive property. So if we look at these pictures, they all have different masses and different volumes. But they'll all give the same density. That's a property of that material or substance. The equation for density is equal to mass over volume. And once you get good at chemistry, you'll have that equation memorized. Units you'll see for density is grams per mil or grams per centimeter cube. Remembering that a centimeter cube, we think of a cube 1 centimeter each on each side, is equal to 1 mil. Mass, you can sometimes use kilograms, but we want it in grams usually, over volume, which is in milliliters or centimeters cubed. If you have a hard time manipulating the density equals mass over volume equation so that you solve for volume or mass, you can use what's called the DMV triangle. So you have density equals mass over volume, but now let's say you want to solve for volume, that's equal to mass over density. So if you go to the DMV triangle, if we have volume, that's what we're solving for, it's going to be mass divided by density. Or if we had density, it was mass over volume. Now if we're solving for mass, it's density times the volume. And that's how you use the DMV triangle. Otherwise, if you're good with algebra, you'll just do the normal manipulation you would do. Now let's look at particles or material within the square. So if we look at this in terms of density, if the squares are the same size, if you look at the images on the left, this square here is less dense than this square here because there's less particles inside. So if you look at the squares on the right, this square here has on the far right is smaller volume. Therefore, because the volume is smaller, what's inside is more concentrated, and therefore it's more dense than this square right here. So that's how density relates to volume. Now, something you may see on the regular is like salad dressing, and it separates on the shelves. You may see where your grocery store shopping or if it's in your cabinet at home. So with salad dressing, if you look at the densities of the oil versus the vinegar layer, the vinegar is going to be at the bottom because the density is higher, 1.006, than the density of the oil, which is 0.918. Okay, example 1 for density calculations. A metal ball has a mass of 2,000 grams and a volume of 60 centimeters cubed. What is the density? So I remember density is equal to mass over volume. Then I'm going to write down what each value is that I can get from what's written in the problem. Mass was 2,000 and volume is 60. And then I put a question mark for D because we don't know, we're going to solve for that density. We don't know that answer yet. So since I know I'm using density is equal to mass over volume equation, I plug in the values for density and, I plug in the volumes for mass and volume. That's 2,000 over 60. And then you can put that in your calculator. 30.3 continued. And then I'm going to look at sig figs, significant figures. It's the division. Use the least amount of sig figs. So 3 sig figs, final answer is 33.3. And then make sure when you're writing your final answer, you have the units, which is grams per mil or grams per centimeter cubed for your final answer. So while you're working problems at home, I actually this is everything I would write out as I'm going along on paper. And when you do that and follow this process, it helps you with your problem solving skills in chemistry, but also in just science in general. Example 2. Water has a density of 1 grams per mil. So that's something you might want to take note of. People kind of use that as common knowledge once they get better as chemistry. Will an object with a density of 1.9 grams per mil sink or float in the water? So it's going to sink. The object is 1.9 for density. That's more dense than the 1.0. The units are the same, so I know I can compare. That's how I know it would sink. Example 3. Find the mass of a chunk of material that is much heavier than a scale's limit or balance limit. The scale that will not make the mass readings above 300 grams. Lead metal has a density of 2.200 grams per mil. This chunk takes up 258 centimeters cube of space. So I write down what we have and what we're looking for. We're looking for mass here. And then remind myself 1 centimeter cube is equal to 1 mil. Then I know I'm using the density equation, but I'm solving for mass, so I would need to manipulate that equation to where I'm solving for mass. So mass is equal to density times volume. So then I plug in density and volume and multiply those together. 2.200 times 258, 567.6. Then I do my rounding. This multiplication, use the least amount of sig figs. So I need 3 because 2.00 is 4. I need to round up because the 0.6 is above 5, so it's 568 for my final answer. And don't forget units, grams. And you can double check your units by seeing what cancels. Mils is the same as centimeters cubed. They cancel. Grams is left. Example 4. A graduated cylinder has a 50.0 mil of water, and then a 1.30 gram key is placed in the graduated cylinder. The graduated cylinder reads 52.0 mils. And then it basically just wants to know what's the density. So this is an example of water displacement. So first, you do the write down what you have for mass, such as 1.30 grams. And then now you do initial and final volume because you want to figure out your total volume in the end. And then you're solving for density, so that's a question mark. Volume. It's final minus initial volume. So 52 minus 50 is 2. You keep your decimal places the same when you're subtracting and adding. Density is mass over volume. So I plug in the mass and that 2.0 for the volume now, because that's the total volume. That's the water, the key displaced. .65, you put that in your calculator. Yep, 0.65. And we want the least amount of sig figs, is division, so that's 2 for 2.0. 1.30 has 3 sig figs. Final answer is 0.65. That's 2 sig figs, and I put down my units, grams per mil as my final answer. Again, I'm just showing the 2 SF to let you know what the sig figs are. We're not necessarily looking for you when you're solving these problems, usually to write that down. We're looking for you to usually show your work, like especially if you're doing some type of quiz or exam in class, and then your final answer with the appropriate amount of sig figs. Well, that's all I have for this lesson. Make sure to like and subscribe and leave a comment. Let me know if you like more of these videos. Thank you. Bye.